We're going to be talking about sequences, and eventually we're going to get to series. A lot of this, many of you have probably seen before, whether it was in pre-calculus or maybe discrete math or maybe even math 3 or algebra 2. You might have seen some of this stuff before. So hopefully it's mostly review, although a little bit of it might be new to you. First of all, there's two ways that you can write the formula of sequences. One way is called the explicit formula. With the explicit formula, what happens is that you have an equation and it says Tn. It could say An or Bn or Cn, just depends on however it's labeled, equals n squared over n plus 2. If I wanted to find the first 3 terms of this sequence, then what I would do is I would let n be 1, that would be the first term. I would let n equals 2, that would be the second term. And then n equals 3 would give you the third term. So if you plug in a 1, you get 1 over 3. If you plug in a 2, you get 4 over 4, which is 1. If you plug in a 3, you get 9 over 5. And there's the first 3 terms of the sequence. When it's explicit, you explicitly plug in 1 and 2 or 3 or whatever term you might be looking for to figure out what that equation represents. Here's one more example of an explicit formula. Just wanted to talk to you about it so that you could recognize it. If I wanted to find the first 3 terms, I'd start with n equals 1, n equals 2, n equals 3, just like I did earlier. And you'd plug in a 1. Alright, if I plug in 1 into this part right here, I get a 5. If I plug in a 1 into this first part, that's negative 1 to the first, which is negative, so my first term is negative 5. Alright, then if I plug in a 2, well, negative 1 squared is 1, so it's going to be positive. And then 2 into the second part would be 2 plus 6, so you get 8. If I plug in 3, negative 1 to the third is negative 1. And then 2 plus 3 times 3, that would be 11. And it's negative. What happens is the terms, the 5, 8, 11, they come out to be just the normal sequence. And then the negative 1 to the n makes the term alternate. Because negative 1 to the first was negative, that meant the first one was negative, and then it alternates back and forth. Right, another form of a sequence is called a recursive formula. And something that's different about a recursive formula is that you can't just look at the sequence and figure out like what the 50th term is. On the last 2, you could just plug in a 50, that would tell you the 50th term. With a recursive formula, you have to know the term before it. So in order to get the 50th term, I would have to get the 49th term, which means I'd have to have the 48th and then so on. So here's an example of a recursive formula. A recursive formula has 2 parts. It tells you what you start with, or it tells you a starting value, and then it tells you the formula. So what this says is A1 is 5, so the first term is 5. Okay, it says AN is 5 times AN minus 1. Okay, the subscripts, the n and the n minus 1 represents the term. So if I wanted to find A2, which is the second term, then that would be 5 times, and then plug in 2, A1. So that means 5 times the first term, which means you get 25. If I wanted to find A3, the third term, if I plug a 3 right here for n, that'd be 3 minus 1, which is 2, so it'd be 5 times A2, 5 times the second term, and then so on. Basically, AN minus 1 means the term before what you're looking for. So if I was looking for the 50th term, then the A50 would be 5 times A49, which is the 49th term. Okay. With recursive formulas, there's lots of different ways that they can be written, so that was one example. Here's another example of a recursive formula. this particular example tells you the first two terms. And the formula says that you take the term before it and then add 2 times the term before that. So if I was looking for the third term, because I know the first term and I know the second term, but if I wanted the third term, well, it would be the second term, because that's the term before it, plus 2 times, plug in that 3, 2 times the first term. So in this case, it would be 5 plus 2 times 2, which would be 9. If I wanted the A4 term, the fourth term, well, that would be the third term plus 2 times the second term. So that's going to be 9 plus 2 times 5, which would be 19. Alright, one more recursive formula that I just wanted to show you. A1 is 10, AN is 5, AN minus 1 plus n squared. Alright, if I want the second term, well, that would be 5 times the first term, plus, since I'm looking for the second term, 2 is n, so it would be plus 2 squared. So 10 would be my first term. My second term would be 5 times 10, which is 50, plus 4. So it would be 54. If I want the third term, it would be 5 times the second term, because that's the term before it, plus 3 squared. So that would be 5 times 54 plus 9. I think that gives you 279. You can continue. Now, all the sequences that we've been looking at, there's lots of different kinds of sequences, but there's 2 really important ones that we want to talk about. The first one is an arithmetic sequence. An arithmetic sequence is a sequence where you're adding the same thing every time. This particular sequence is arithmetic because I'm adding 6 every time. Now, what you're going to find out is that arithmetic sequences are always linear. So if I want to write the explicit formula, which is the formula to represent this sequence, what I'm going to do is I'm going to write an equation of a line. So I'm going to write it in the form of y equals mx plus b, or an equals m times n plus b, slope plus y-intercept. And I'm just plugging in n, because normally that's whatever term you're looking for. Alright, so the slope here is the amount that you're going up by. So an equals 6 times n, and then you have to find your b. Your b is the y-intercept, your b is your initial term, a0. Well, our initial term in these cases is like the first term. That's like the point where the x value is 1. So to get b, what you do is you go backwards. So you find whatever term was really before the first term, which means in this case that you would subtract 6. So negative 1 becomes like the a0 term. And that gives you 6n plus, or you could write 6n minus 1. If you weren't sure, you could put that, put values in for n and find out that you really do get the values that we're looking for. Here's another one. This one is still arithmetic because I am subtracting a half every time to get to the next term. So if I'm going to write the explicit formula here, then it's going to be an equals negative a half, because that's the slope, n. And then to get this term here, it's the term before the 1. So it's like going backwards with it. So that's like adding a half. So it would be plus 1.5 or plus 3/2. Now, both of those formulas that we just did were explicit formulas. So let's go back for just a second. We also may have to write them recursively. If you write them recursively, what you do is you start off by saying what the first term is. And then for the part of the formula, see, we're adding 6 every time. So what you say is you take the previous term, which is an minus 1, plus 6. So on this one, it would be a1 is 1, you say the first term, and then you say, okay, I'm subtracting a half every time, so I say an minus 1 minus a half. So that's just two different kinds of formulas. Alright, geometric is another big type of sequence that you have to know. Arithmetic means you're adding or subtracting something every time. It's linear. Geometric is exponential. It means that you're multiplying by something every time, or dividing. So let's say we have 12, 4, 4/3, and 4/9. So in this case, what we're doing is we're dividing by 3. Now, whenever we figure out what we're doing every time, we've got to make it a multiply. So I'll show you that in just a second, how that's important to the formula. But in this case, you are dividing by 3, which means you're multiplying by a third. And so we say that R, which the ratio, is 1/3. R is whatever you multiply by every time. Now there's a formula for geometric sequences, and this is the formula: an equals the first term times whatever you're multiplying by to the n minus 1. You need to know that formula. So here, if I'm going to write the formula, it would be 12, because that's the first term, times 1/3 to the n minus 1. If I were going to write this recursively, I would say a1 equals 12, and an is the previous term. You could put times a third, you could put divided by 3, both of those would be the same. Or you could put a third an minus 1. Alright, here's another one. On this one, we are multiplying by -3 every time. So that means that R is 3. That's why it's geometric, because you're multiplying by something every time. So a1 times R to the n minus 1, that is the formula. If I wanted to write it recursively, a1 would equal -2, an would equal the previous term, times, you know what, these are supposed to be -3s, because -3 change into a positive, and then when you multiply by another negative, that makes it another negative. So these are all -3s that you're multiplying by every time. Alright, I have a couple other kind of examples just to show you real quick about arithmetic and geometric sequences. Let's say that you have an arithmetic sequence, and we know that the 10th term is 43, and we know that the 15th term is 68. And the question maybe would ask us to find the formula for the sequence, or maybe to find the first term. So what I know about arithmetic is that it's linear. So I know, first of all, that I can get the slope. These, the 68 and the 43, are like the y values. The 15 and the 10 are the x values. So I'm just going to do like I normally do with slope, subtract the y's over subtracting the x's. You get 5. So if I want to find the equation of the sequence, I'm just going to do it like I do y equals mx plus b, and then I could find the equation. Pick one of the points. I usually just pick the smallest. So y equals mx plus b. b is -7, so your equation is y equals 5x minus 7. If I wanted to know the first term, I would plug in 1 in for x, and I would get -2. If you wanted to write this as an equals 5n minus 7, that's okay too. Just so you know what everything represents. Alright, here's a geometric example. And it's a little different because since it's exponential, we don't know as many formulas there. Let's say that you have A7 equals 4,374 and A10 equals 118,098. Alright, what you do is you start to find R. And R, what you do is you divide the two numbers. And you raise it to a power, or you take the cube root, or you take a root, depending on how much you're going up. Now you see I'm going from 7 to 10. That means I'm going up 3 times. So that meant I had to multiply something 3 times. So what I want to do is I want to take the cube root. If it would have been going up like 5 times, that meant I multiplied something 5 times. So then I would take the fifth root to see what that would equal. Alright, I end up getting a 3 here. So that means that every time I'm multiplying by 3. So to figure out the formula, pick one of the points and sort of plug it in. I know that A1 times R to the n minus 1 is the formula. Well, if I set that equal to like the equation, then I can just plug in the numbers. So A1 times 3, let's say to the 7 minus 1, is A7, or 4,374. And if you divide that, 3 to the 6 divided by, you get A1 is 6. So that means that your equation here would have been AN equals 6 times 3 to the n minus 1. If it wanted to know what the first term was, then you could plug a 1 in and you would get 6. Alright, last thing I want to show you has to do with converging and diverging. And this sort of has to do with limits. So we are going back to limits in this unit. Converging means that the limit as you approach infinity is a number. Diverging means that the limit as you approach something is either infinity or negative infinity or undefined. Undefined is not as common, but it's possible. First of all, if you have an arithmetic series or sequence, sequence, they always diverge. Because think about it, any sequence that I have that is arithmetic would look like a line if I connected the points. And so if it's a line, it's either always going up or it's always going down. And so the limit for an arithmetic sequence is always going to be either infinity or negative infinity. So that's why they always diverge. Now, geometric sequences, there's a couple cases here. I told you earlier that a geometric sequence was an exponential function. So geometric sequences, if I connected the points, because really they're just points, the sequence is. But if I connect them, I get exponential and they look kind of like this. Well, this one diverges because if you look at it, the limit as n approaches infinity is infinity. This one over here converges because the limit as n approaches infinity is 0. Now, the thing that makes the exponential function either go up like that or go down is the r. And if r is less than 1, it's actually the absolute value because I don't care about the negative, then it will converge. Otherwise, the series is going to diverge. So if you have a geometric sequence, it converges if the ratio, the thing you're multiplying by every time, is less than 1, and it diverges all other times. So let's look at some examples. Let's say you have an equals 0.2 to the n. Alright, this is a geometric sequence, And I know this because it's sort of in the form. The form that we talked about was a1 times r to the n minus 1. That can be an n or an n minus 1. That's just the standard formula. So the a1 here is like a 1, and the r is like a 0.2. So that's why that is a geometric sequence. This one converges because it's geometric, and r is less than 1. Which means it converges to 0 because the limit of this sequence is 0. Okay, this one diverges because it's geometric and r is bigger than 1. Another way you can say that is the limit as n approaches infinity of a(n) is infinity, because this is an exponential function going up forever. Anytime you're trying to find whether it converges or diverges, basically what you're trying to figure out is what's the limit of that sequence. Alright, 4n minus 7 is a line. It's going up forever because the slope is positive. So this is going towards infinity. So this diverges. You can't just say converges or diverges. You have to have a reason. If you have a(n) equals 2n plus negative 2n plus 1, this limit is still a line, but the slope is negative. So that means it's going down every time, but it still diverges. Alright, another example. This one is not arithmetic or geometric, but I know the limit of this as n approaches infinity. As you approach infinity, you're looking for the horizontal asymptotes. Remember the rules. Top is bigger than the bottom, is a slant. Bottom is bigger than top. The limit is 0. And top and bottom are the same. The limit is the coefficients. So the limit here is 5, which means it converges. So basically, if you find the limit and you get a number, then the answer is converges. Alright. a(n) equals 5n plus 3. Well, the limit as n approaches infinity of this sequence is 0 because the top is a less degree than the bottom. So it converges. Now, there's two more sort of weird cases. Let's say that we have a(n) equals negative 1 to the n times 2n over n minus 1. Now, what I know here is that if I didn't have that negative 1 to the n, this part right here, the limit would be 2. But that negative 1 to the n, what it does is it takes the values that are approaching 2, and every other one makes them opposite. So sometimes on these, I just sort of plug in some numbers so I can look at it. So for the first term, if I plug in 1, well, it looks like there's not really a first term, it's undefined. So let's start with 2, because 1 minus 1 on the bottom would give you 0. So let's do 2. Negative 1 to the 2, that would be positive, and then plug in 2 in the other part, so you would get a 4. Alright, and then if I plug in a 3, I know my next one's going to be negative, and then plugging in a 3 over there, I would be 6 over 2, so I get negative 3. Alright, plugging in a 4 would be positive, and then it would be 8/3. Plug in a 5, it would be negative, and it would be 10 over 4, or 5/2. And what I can tell is that if I look at the 4 and the 8/3, that part's getting smaller, maybe towards, I don't know what it's going towards, probably 2 to be honest with you. And then if I look at the negative 3 and the negative 5/2, those are going towards negative 2. So it's kind of like the second term is 4, the third term is negative 3, the fourth term is a little bit more than 2, the fifth term is a little bit closer to negative half, so what it looks, negative 5 halves. And so what it looks like is that the positive terms are going towards 2, and the negative terms are going towards negative 2, so this diverges. Most of the time, if there's a limit, like 2n over n minus 1, if that's equal to 2, and then you have a negative 1 to the n, that most of the time that will diverge because it's making part of them go toward the positive part and part of them go to the negative part. Now, this next one is a little different. It still is something where it's changing positive and negative, but the limit of this part right here is 0, and so what ends up happening on this is that this part goes towards 0 and this part goes towards 0, and so since both parts are going towards 0, this is going to converge. And the reason basically is because the limit of that inside part is 0. If that happens, positive and negatives, they'll still both go to 0, so it can converge. You could plug in some numbers to look at it and see, but that's basically what's happening. Alright, here's your try problems. On 1 and 2, I just want you to write the recursive and the explicit equations. Those are arithmetic and geometric, so just look at those. And then on 3, 4, and 5, I want you to figure out if it converges or diverges. And your reason why it converges or diverges is whatever the limit is. So you find the limit and then you say whether it converges or diverges.